And today we are finally going to look at some technology. I was kind of getting frustrated that we were just talking about books and drawing squares and stuff. So instead of doing kind of the next step that's defined in that Mere Mortals book, I wanted to actually jump over to Postgres to start looking at how we can start building these databases that we're talking about. And there are a couple ways that we can do this. We have Postgres running in Docker. Some of you may have installed like the full Postgres on your Windows machine. That's fine too. So there are 100 different ways we can interact with this database. I'm going to start by working like at the command line. There's a tool called pSQL, PostgreSQL. It's a command line interactive database thing. But I'm also going to use a tool called SQL Developer. It's from Oracle. I've used this literally for 20 years, and the product itself has not changed. It's basically the same thing that it was when I first started my career. What I like about it is that it is simple, and we don't get distracted by any sort of features or anything in the tool we're using to interact with the database. It'll allow us to write SQL scripts and save them as files and edit them and run them, and that's pretty much what it does for us. So I'll be using that probably heavily throughout our examples. But if you decide to use the built-in Postgres interface, great. If you decide to use the command line interface, great. Doesn't matter to me. When we do homeworks with deliverables that are SQL, I will want a SQL file, and I don't care how you generated it. Well, with one caveat. I don't want you to like use a GUI tool to build a database and then hit like export as SQL. That would be really bad. And I'll be able to tell, promise. But anyway, I want you to write your SQL by hand, and we will learn that way. So using these links, the first one is a link to SQL Developer. I'll show you that today. The second one is, since it's an Oracle purpose-built tool, it's a Java tool, and it uses JDBC, which is the generic Java database interaction library stuff. So you'll have to install a JDBC driver for Postgres into this database. And instructions are super, super simple to do that. You download a jar file, you put it in a magic place, and it just kind of works. Anyway, we'll look at these tools. Another thing to know, if you are running Docker, over time you might realize, why is my disk full? Or why does it tell me that I already have a Docker container by that name when I just want to run a quick Postgres Docker thing? So there's this command to, this works on my Mac. I don't know I don't know how to do it on Windows. We'll figure that out. But basically, you run this command, and it finds all stopped Docker containers and then removes them. So I didn't have any stopped containers right now, so it didn't do anything. But on a Mac, that works, and I'm sure we can find a Windows equivalent. All right.
Quick question, please.
Yes.
What is stopped container? Like something no longer works, or?
So do you remember this command that we ran, something like this?
Yes.
What this does is it runs a Postgres container. A container is like a virtual machine, but it's not a virtual machine, but it's kind of like a virtual machine. So it will run an instance of this database in an isolated, I'm trying not to use the word container, an isolated process on your computer that runs a full Postgres engine, but it doesn't have access to your file system. It doesn't have access to other things running on the server. It runs in its own environment, managing its own dependencies and all that. So you don't have to install those on your operating system.
So why is it called stopped Docker containers? I'm just curious.
Yeah.
The way it was named.
So Docker is the name of the container technology, and their their logo looks like a shipping container. You know, a big old ship with hundreds of different little containers on them, each with cars or little toys or whatever is being shipped overseas. And the analogy is that the Docker is the ship, and the processes we run like Postgres are the little containers on the top of the ship. Doesn't matter what's in every container compared to the other containers on the ship, but it's running its own thing.
And why do we say stopped? Like because we're not using it, so it's stopped?
Yeah, when you aren't using it, you want to stop your containers. When you do want to use the database, you'll stop it or you'll start it. So
Gotcha.
you run instead, not start. You run and you stop.
All right, thank you.
Yep. And I can show you that real quick in a couple of different ways. So in this window, I will run my Postgres container. And that's it. Now I have a Postgres database running. And if I want to use Docker, I can see that I have one running. And it's named some Postgres. And I think I can just stop it. So now it is no longer running. And then if I want to delete that one, I delete it. And I no longer have one either running or stopped. All right. So when you are running your Docker container, remember the $sign is the beginning of my terminal interaction. When you copy and paste this line, you don't copy and paste that $sign. So I'm going to follow my own instructions as we do this. I am going to start a Docker instance in this window. So now I have a Docker container running. And what I'm going to do is grab this one, and I will side by side these just so you can see. The one on the right is the actual database engine. The one on the left is another terminal window that I can do something else in. So I'm now running a Postgres database, and today we're going to start interacting with that database. So, like I said, there are a couple of ways to do this. The first way I'll do from the command line. So I'm going to run it's another Docker command. It's going to execute on the some Postgres server the command pSQL. And a parameter to pSQL is what user I want to connect as. So in the database, this is covered heavily in chapter 2 or 3 of the Postgres book. We'll get into it a little more, but for today, there's a hierarchy of things in your database. You have the database engine, which is Postgres. It runs all these things. There are schemas, which are different namespaces within the database, so we can create tables in those schemas that are separated from each other. So I could have my own schema. We could have a reporting schema. We could have a production relational or a production transactional database schema that run in separate. They run separately as to not really interact with each other. We also have users. Users have rights and access to different schemas or different tables or different views, as we learned about. All this is managed by the database itself. So the first thing I want to do is connect to my database using this command line. So in my left window, let me make that a little bigger, I'm going to execute this connection. And pSQL is the interface, the application to connect to the database. So you'll see my prompt changed, and I am now in a pSQL interface. Everybody nod, thumbs up. It's just a command line application. All right, from there, I'm going to be flipping back and forth a lot. So I'm going to try not to do it too quickly, but I will be doing it regularly. And you can always go back and watch and pause and all that good stuff of the video. I'm going to take a SQL query and execute it in this window. What this SQL query is, it's selecting some data, dat name, dat DBA, encoding, just a couple pieces of data from the PG database table in the schema PG catalog. The purpose of today is not to teach about different schemas and users and all that stuff. We'll get to that. But when I run this, I'm executing a query against a table in the database. This is not a user table. This is a system table that tells us what databases or what databases our database engine is running. So database engine runs multiple databases. Databases have multiple schemas. It's a little hierarchy. But specifically, this is the PG catalog schema in the database. So you'll see I have a couple of database names in here. They're not terribly important for right now. But I'm starting to interact with my database. Yay, technology. So let's start making some tables. We're going to go into SQL pretty heavy today. We'll be creating tables, keys, indexes, inserting data, all that kind of stuff. So when you're working in your database, the first thing we typically want to do is create a table. And as we know, our tables or relations are where we store data. So going from, this is a quick example. We are going to create a customer table with one column. That column is a customer ID. I'll tell you what serial is in a minute. So I'm back to my P-SQL interface, and I'll create a table customer. And that response says it worked. There's a magic \DT command that shows me the tables in my database. So I now have, and they even use the word relations. I have a new relation called customer. Little metadata about it. But the important part is now we have a customer table. So the syntax create table is the command. The command is create. So we're creating something in our database. We are creating a table. We are naming it customer. And we're in the parentheses, we supply the list of columns or attributes or attributes for our table. Everybody with me so far? No? Or maybe?
Yes.
Yes.
Yeah.
Anyone not with me?
I so when I copy and pasted the Docker execti some Postgres, it says it's not found now. It was working a few weeks ago.
Is your Docker on?
Yeah.
Did you run the first command, the docker run?
I did. And it said it's not found. So no such containers. And that was interesting.
So I have a feeling for some reason this docker run did not work.
Right, it did not. Yeah, but it was working fine. Yeah, I'll try it later.
Okay, yeah, just follow along for now, and at the end of class, if you're still having issues, we can look at it. Okay, so once we're in here, everybody's with me on creating tables. So we'll go into more about those tables, but for now, we've created one table, and the SQL query keyword is select. So I select some data. In this case, that star represents I want every field on that table. Select star from. From is going to say, after from is the table or view or whatever I'm going to query. And in this case, I want to query the customer table. Anybody have any guesses on how much data is going to be in that table?
How many what? Sorry.
How many records will be in that table?
0.
Yeah,
0.
we haven't put anything in there yet. So I'll select star from customer, and 0 rows were returned. Cool. We're going to be selecting a lot of things. So select data from table. Okay, now let's start thinking about an actual use for our database. The first one was really just to show the create table concept. But now I want to start building a script that can be used to build a full database. This is where I am going to use SQL Developer just because I like it. Where is my SQL Developer? Here it comes. Let me close these. All right. So this is what an empty SQL Developer looks like. Not much to it. But what we do is we want to, create a connection. I hit the little green plus sign. A database type, I'm selecting Postgres. Just going to give it a little name, give it a little color. My username, I believe, is Postgres. And my password is my secret password. I want to save it. And since I'm running in a Docker container, I'm running locally in my local host, my local computer. And let's see, it exposes port 5432 for where the database is. So maybe it doesn't. I didn't tell it to do that. Let me fix that real quick. So I need to stop that. I think I'm missing some parameters here. I'll update the docs here. But I'm telling it I want to expose port 5432 as port 5432 locally. And that should work better. So now I go back to my SQL Developer, choose database. There we go. That's what I was looking for. And now here I can check the default database that I want to use. For now, I'm using the default Postgres database in the database engine. I'll hit save, and then I'm going to hit connect. I thought I hit save on the password, but that's okay. All right. This is basically a text editor, or it is a text editor. So I can select star from, I forget the name of the table, so I'm going to go look over here on the left. I'm drilling down into week 4 DB, Postgres, the public schema, tables, or no. Yeah, I thought it was in tables. Oh, I didn't, sorry. Since I deleted it, I have to start over. All right, so I just recreated that table again. When I stopped and removed the Postgres that I was running, it deleted that table. It started fresh. So I just had to create that real quick. So now I hit refresh, and I have a table called customer. So select star from customer. And there's a couple, I know this is super tiny, I'm sorry for that. I don't think I can make this bigger. I don't think I can make this bigger. I'm going to hit the play button. Next, run script. And it shows me the output down here. No rows selected, which is what I expected because we didn't put anything in there. All right. Let's start building this table. So, yep.
Question.
Yep.
Earlier, I see the no selected data or whatever. It appears twice.
I don't know why.
does it?
I don't know why. I don't think I hit play twice. No, I just hit it once. I don't know why it's doing that. All right. So the way I start my scripts, we are going to be building the tables that were early in the book around page 14. So remember agents and clients and all that. Agents, clients, entertainers, and engagements. So let's walk through this. For a script like this, since I know I'm in a development kind of mode, I'm going to build a script that's going to create all the data structures and then start inserting data into it. I want to be able to hit just play over and over again. So I always start by dropping my table structures. That way, if I make a change in the creation of the table, the table goes away when I start. So I don't have to deal with conflicts and altering the table. We'll get to that later. But for now, this is how I like to build my scripts. So I'm going to create my agents table and create 5 columns in that table. The first will be an agent ID, data type integer, with a primary key, as the primary key. So this is telling the database as the primary key, it cannot be null and it must have a unique value. We've talked about that a bunch. Then I'm going to add a first and a last name using varchars or variable character lengths of up to 255 characters. I'm going to create a date of hire and an agent home phone number. So again, the parentheses around this whole thing, I'll give some white space to make it a little easier to see that, surrounds the list of columns. So our table name is agents. Then we have the name of the column and the data type next. Int, varchar, date. Whatever we decide for this table after we go through our analysis and design. So now I'll run this script and we'll see table agents does not exist, so it's skipping. So I've dropped table if it exists. Then it still tells me it was dropped, but then it created the agent table. So looking at my tree on the left now, I have an agents table. Just showing the tool a little bit more. I clicked on the table. The first thing it does up here is it shows me all the columns in that table. Agent ID, first name, etc. This is giving us more metadata than we provided. So there is no default for the column. It is the first one is the only one that is not nullable, meaning it cannot have a null value, or it needs a value. The other 4 are nullable as we've created it so far. The data type is listed, the max size, and for numeric things, it's a precision and scale. So precision says how big can this number be. So we have created a table. Now, when we start looking at this for homework, I will do something like save. I'm saving this SQL script, and week4db.sql sounds good to me. So now I can come back later and open and modify this script and then upload it for homework. So the next natural thing is to insert data into our tables. After I've created the structure in this script, I can now insert data. Syntax, insert into the agents table. Then I'm specifying the fields that I'm putting data into. Agent ID, first name, last name, date of hire, agent home phone. Then the keyword values.
Maybe I missed it, but somebody talked about how the PDF you can download online from your GitHub page. All the code and like the darker rectangles are blank. You can't like no code in that PDF.
Really?
Yeah.
Yeah.
Oh.
So I haven't been able to. Like, I'm just looking on yours. I'm not haven't gone and taken the code and done it.
Okay.
Myself so far.
Thank you for pointing that out. I will figure out what's going on. You can always click on the date here, and that's the actual slides.
Oh, okay. Cool. Thanks.
Yep. That's really odd. Huh. Okay.
Yeah, like even if we try to send it as PDF, it will cut the code.
Weird.
But if you click on that link, like you showed us the actual date, it works.
Yeah. That's all I do is I just print this out as a PDF. So interesting. Sorry about that. I will explicitly look at that next time and see if I can figure out what's going on. But for now, if you want to follow the slides, you're welcome to, obviously.
Thank you.
Yep. So in this case, if you look at the syntax here, each tuple, each row that I'm putting into the table is surrounded by parentheses. And inside is a comma-separated list of the values. So I'm creating agent ID 100 as Mike Hernandez, hired on 5/16/2011, with a phone number of 553-3992. Greg Johnson, Catherine Ehrlich. Alternatively, I could do these one at a time. So I could have a insert statement for each of these rows. For purposes of this exercise, though, I'm going to insert them all at one time. So now my table does have an agent, or my schema has a agents table. And so when I run this script, it will drop it. Whoops, let me clear it and it'll make it look better. So you'll see the first thing, it dropped the table. Then it created the table and it inserted those rows. So to get those rows, select star from agents. Another thing I can do in SQL Developer if I want, I can highlight just one command to run. And so when I hit the execute, it'll just execute the highlighted stuff. So here you can see it outputted all my data. One thing I don't like is these are 255 character strings, or up to. And so it pads it like that. I can hit instead of the script button, I can hit just the green arrow, and the output is a little different. It gives me more of a spreadsheet feeling output. So I can copy and paste individual records and rows or columns, fields, that kind of stuff.
You can use trim commands for that and things as well, right? Like trim the spaces.
I think so. Let me see. Let's experiment. That's why I love computers. I can just figure that out. I try to capitalize all my keywords and then lowercase the things that are not keywords. So let's see. If I run this one, script output, I'll get a full name, but then I'm going to apply a function, I think, to the agent first name.
Yeah, I'm not sure if you. Oh.
Yeah, I don't know what the command is.
I think there's something about trailing.
Yeah, I don't know. But I tend to like this output better anyway, because I'm used to spreadsheets. So that's how I can get that data back out. All right, inserts into the agent table. Cool, I did that. Foreign keys. So now we know our agents hire clients or find clients. So our clients table is being created next with a client ID serial. Again, I'll talk about serial in a minute. The first one I created an int field. This time I'm doing a serial field. Again, primary key on my clients table. I am adding an agent ID column as well, and then a first and a last name. Now the agent ID on the clients table is a foreign key to the agents table. The agents table agent ID is the primary key. And so what we do, we'll say it is not null. It has to have an integer value. It's not nullable. And it references the agents table, specifically the agent ID field. So let me drop this one if it exists. So I will run my script. And I have now created my clients table. If I look back at the metadata, we will see that this doesn't, I think it's the model tells us the, oops. Cool picture. ER diagram, right? The client's agent ID foreign key references the public agents table, or the agents table, sorry. I don't think I realized it would build us a proper ER diagram. So now, what happens when we want to insert data? Insert into clients, agent ID, first name, last name, values, anyone want to guess what's going to happen when I insert this record?
I think because you're using serial, that should automatically increment to 103, so it's going to allow you to do it. Let's see. Yeah, that's good.
Error.
Brian?
Some sort of error.
Why?
Something with the foreign key.
Okay. What do you think? You are correct. It will be an error.
Oh, wait, yeah, because it's dependent on the agents table.
Mm-hmm.
That's why.
And so I'm trying to insert an agent ID of 444. I don't have an agent ID of 444. So when I run this, I get an error. Insert or update on table clients violates the foreign key constraint. Agent ID 444 is not present in the table agents. So that's an explicit way of saying the inverse of the foreign key value must be present in the primary key of the referenced table. Yes, I said that right. The foreign key value on our client's table must exist in the primary key of the referenced table, which in this case is agents. So let's correct that, and we'll assign me to agent Catherine Ehrlich with client ID or agent ID 102. I will hit run, and I got one row inserted. Greg, I think you were on the right path. What is the value of the client ID for Chris Fauerbach? Because I did not specify it.
The value of the client ID would be
Agent ID. Oh, yeah, sorry, client ID. Yeah, sorry.
that should be, I think it was 1 of 3, whatever the next one-up number would be.
Yeah, so I think by default it'll start at 1 in this table. So a serial. No, let's check that first. So in the clients table, I'll pull data. Oh, it's 2 for some reason. Oh, I know why. Because the first one failed, but it still reserved that number 1. But now if I insert another record, what?
103 doesn't exist.
Oh, it didn't? Oh, whoops. Thank you. See, I confused myself. Now I should have a 4. Because again, what it's doing when I look at the actual columns of this table, we did the failed foreign keys. That it's documented in the slides too. What a sequence is. So in Postgres, a sequence is a special kind of database object that generates a sequence of integers. If anyone's used MySQL, you've got the auto increment concept. The sequence is a generator of integers that by default it's a counter. So the first time you pull the data from this sequence, it's another magic data type or another structure in the database. It'll get every time you get the next value, it will increment it by 1. It's a super simple way of generating a primary key, because every time you reference this sequence, you'll get the next unique number. There are configurables on a sequence. So you can get increment by 1, increment by 2, increment by 10, whatever. But it's generating a unique list of numbers. And so to use a quick way of using a sequence as the primary key, well, sequences will regularly be used as primary keys first. Second, it doesn't have to be. It can still just be a integer value on the table. So in this case, I did not specify this as a primary key, but it very well could be. So the field data type is serial. And what that does, it does a couple of different things. It's called a pseudotype because the serial is not really a type of its own. It's an integer type. And when you create a serial pseudotype column, it does a couple of things. It creates a sequence object behind the scenes. And every time you insert a record, it sets the next value generated by the sequence as the value in this serial column, and adds a not null constraint. So looking back at this metadata, the default value for this client ID field is nextVal, which is a function to get the next value from the name of the sequence. But it's still an integer type.
Professor,
Mm-hmm.
You said like when you created an error record, like when you tried to insert invalid value, the number for the client ID, it was reserved by the database, although you didn't insert anything.
Yep.
So how can we solve this problem?
I don't think it's a problem, because I think the word reserved, which I did use the word reserved isn't exactly right, because that number is not stored somewhere as referencing a table field or column or anything like that. If you think about the sequence as another, how do I want to describe it? Like a table, like a view, like a something. It's another one of those top level objects in the database where all it does is it keeps track of its next value. So there might be more commands on it, but next val is the primary command that we use when interacting with a sequence, and all it does is it returns that next value and then increments its own counter. So if we were doing regular programming, it would just be a variable that remembers the last value it was set to, and every time you want the next value, it adds one to itself. So it doesn't remember anything. It's a very lightweight kind of construct. But I think order of operations when we're inserting data into the table, the first thing the database does is it starts to insert the data, and when it starts to insert the data, it needs that default value, so it's going to get the next value from the sequence. The next step of inserting the data is validating all of those constraints, and that's where it fails. So it rolls back that insert transaction. But the next val command was still called.
Got it. Thank you.
Mm-hmm. And I think we could even, I'm curious if I can be smart enough, select next val from agents. Let's see, what did they name it? Client. Sorry, client ID sequence. Client ID sequence. I'm totally guessing here. Select blank from client. Wait. I'm seeing if I can interact with it. I guess I can. There's probably a way I can interact with it, but that wasn't working. Okay. So now I have that table, or that data in the client's table, and I can extract it. So you'll see the IDs are those sequences. The agent ID is the foreign key to the client. The agent ID, I'm confusing myself. The agent ID is the foreign key to the agent's table primary key. Then the first and last names that we inserted in our SQL statement. Serial can be a bunch of different data sizes. So integer data types, it's how much memory that data type or that field stores. So a small int is a 2-byte integer, meaning it can store from negative 32,768 to positive 32,767. A big int can store up to that number, but a standard integer is within this range. 2 billion, 2.1 billion. So this matters when we're looking at our tables and deciding or defining how big of a number we can store in it. So if we were going to make a table measuring the temperature every second from some temperature sensor, we would probably measure 32,000 different temperature measurements pretty quickly. Would we remember 2.1 billion temperature sensor measurements? Maybe, maybe not. So we have to fit our data range into the size of the data column itself. And the whole reason I'm saying this is there's the equivalent for serials, since they're just a pseudotype on top of integer. So we can have a big serial, which will start at 1 or can start at 1 and can increment up to that number, whatever that number is. So the way you typically use a serial is as that primary key generating construct on a table. So in this case, we have a fruits table we are creating, which has the ID serial. So it's an integer type back with a default value from the sequence and a not null varchar name. So we insert into that table using the regular insert statement without specifying the ID, and it gets auto-generated by the table. When I first came up with these slides last time I taught the class, I was super obsessed with the pawpaw plant because I'd never heard of that before. Apparently it's a big thing in Virginia. It's supposed to be really good fruit, and you can find it in wetlands. And I want to grow them at my house, but I haven't yet. But does everybody follow this SQL? I created my table, fruits. And as we would expect, we have a default value of the ID is the next value from this sequence, and it's an integer type. We can insert data into that table, and then we can select from it, and we will see that ID value being generated. We already talked about what serial really does. It creates the sequence and then uses it as the default value for the column. All right, and so here I have more SQL for us to look at. Come back. So let's continue to build out that example. Well, we'll save that. New SQL statement, new database file, untitled 4. All right. So this first one looks familiar. We'll drop the columns agent, clients, entertainers, and engagements. We'll create our agents table and insert the values. Create the clients table, and we'll insert some client data. So I think in this case I added more data. Oh, I didn't like that. All right. Maybe I can't do that today. That's okay. Inserting the client data. And then this was the one that we kind of showed already what happens when we have a bad foreign key. It violates the foreign key constraint because of that 9345 client ID. Now our entertainers table has its own primary key and another foreign key. Everybody see the foreign key? What table is that foreign key referencing? Agents, yep. Yep, so I'll run that and I'll create my entertainers table. I'm going to insert 3 values into my entertainers table. Then we'll start with engagements. So this one is different. Why is this one different than the others we looked at?
There are 2 foreign keys.
There are 2 foreign keys. Yep. What tables does it reference?
The client ID refers to the clients, and entertainer ID refers to the entertainers.
Yep. That is right. So we have an engagements table. So in real life, when you start writing applications or something to help put data into a table, You typically will not have a SQL script with a whole bunch of insert statements in it. You'll probably have an application on top of your database that will handle finding the foreign key value and all that kind of stuff. But for now, it's just all hard-coded in my SQL script. So I inserted those 3 rows into engagements. And now I can start querying them.
Hey, Chris.
Yes, sir.
Hey, what's the primary key for that engagement table?
There isn't an explicit primary key. If I were to make a primary key, it would probably be a combination of those 4 fields.
Okay. Hey, what if I have duplicate entries, like the same client ID, same entertainer ID, and sometimes in the stop time?
Yep.
Exactly the same. Can I have 2 entries? Same values?
So if the primary key were client and entertainer only, you could only ever have 1 engagement for that client and entertainer. That's probably not good. You couldn't have repeat customers. So then we could say, okay, well, is this our primary key? Basically, is it client ID, entertainer ID, and engagement date? That could be more accurate, but then you can only have 1 engagement on any day. So you couldn't do a morning and an afternoon event. So that's kind of why if I were to use just these columns as a primary key, I'd probably go with these 4. And you can have a multi-column primary key.
Okay. What's the syntax for making all those 4 columns and a primary key?
I believe it is primary key, client ID, entertainer ID, engagement ID, start time. Whoops, sorry, that's my insert statement. That would be on my table creation. Primary key, I think that's it. Let's test it though. This is why I have references. I would look at the book if this isn't right. Nope, that wasn't exactly right. I need another parenthesis. Yep. Did I spell it wrong? Client ID, entertainer ID, entertainment date. Yep, I did that wrong. There you go. So now I have a 4-part primary key.
Thanks.
Yep. And so if it was a single column, that's when I would put primary key at the end. But I can do this as well. And you can also specify a foreign key this way as well too. So instead of putting it at the end of the column definition, I could do a foreign key, entertainer. So I think that should work as well. But again, I think I'm missing a parenthesis. Yep. So these are the 2 different ways I can specify the primary key, or the foreign key as well. So even though it's specified down here, I still have 2 foreign keys on this table. And the reason I know that has to be possible is I can always update a table later and add the foreign key if I didn't do it at creation. And then we can insert that data. Whoops, I messed up a syntax because I was doing stuff. Here we go. Okay. Okay, back to querying. How are we on time? Oh, we have 9 minutes, 10 minutes. Select star from client, agents, clients, entertainers. So I can start pulling these values. And now going to the whole concept of data versus information. This query is useless. Why is this query useless?
You need a view.
I don't need a view.
Well, it doesn't have any name.
That's what I was looking for. I don't know who client ID 9002 is. I don't know entertainer 3001. Nor should I. So we can start looking at ways to join these tables together, because the value of the valuable information comes from the entertainer table, not the engagements table. The valuable stuff in engagements is the date, start time, and the end time. But the valuable things for client information comes from the client's table. The entertainer information comes from the entertainer table. So now I can start joining these together. Now again, there's going to be a couple of different syntaxes to do this. So it all goes back to how I started learning this versus what's newer. So bear with me and we'll see a couple of different ways to do this. So here I'm going to select star, meaning I want everything for right now. I want every column from the clients and the engagements table. Notice what I'm highlighting first. If I execute just that, I'll do it from the tab view. I start to get information. Well, bad information, but I still get information. How many records were in each table? Clients and engagements. Engagements, I had 3. Clients, I had 4. How many rows did I get back?
12. It's duplicate. It's multiplied.
It's multiplied. This is called a Cartesian join, meaning every row from the first table, clients, gets returned with a row from engagements, with no validation on those relationships. To show you what that really looks like, select star from clients engagements, order by clients dot client ID descending. I'm getting 3 client records, 3 records per client ID, when really I've only got 4 engagements in here. So the thing we had to add was this relationship of comparing values. So we want to make sure the client's client ID value equals the engagement's client ID value. So if you picture on the left a client's table, and you picture on the right the engagements table, and you draw a line between the matching rows based on client ID, that's what this equivalency check is doing. So when I run this query, I'll start saying, okay, now I have my client information and my entertainer information, but they match because the client ID 1 is coming from the engagements table, and the client ID over here is coming from the clients table. So now we know Estella has a engagement with entertainer 3001 on the 1st of April 2012. So we're starting to build these relationships in our query that actually mean something. So another way of doing that is to be more explicit in the actual query. Select star from clients, but here I want to inner join on the engagements table, specifically on the client's ID matches the engagements client ID. This is really the preferred query for this. Same results, but this is easier to read in my opinion. So we were still missing that. What were we missing? The entertainer information. We're still missing agent information. And so far, I think we've done select star. So here's a way we can start pulling out specific fields that we want. Agent first name, agent last name, client ID, etc. From clients, interjoining engagements, and then interjoining to the agents table as well. So agent Catherine Ehrlich has a client, Estella Rosales, who has an engagement on April 1st. So we're really starting to pull that data in a way that makes sense. Now I know somebody wanted a view, so we'll make a view. Because this is foundational relationships in our database. I know over time, if we didn't have views, we would build this query 17 million times. And we would put some filters on it sometimes, whether we're filtering specific agents to find their profits or specific clients to see how often they come back. So we know we're going to build this relationship over and over and over again. And this is where we build a view. So I'm going to create or replace view. So instead of create table, I'm creating view. I'm giving it a name, agent client engagement view, because it's joining the syntax. I'm joining those three tables. So that's kind of my naming convention for my view right now. And we have the keyword as. So remember I said earlier that when we create a view, it's really just a SQL statement. We are creating this view as this SQL statement. So now I run that and my view has been created. Now if I look over here, I will have this view, agent client engagement view. And the really good part about this is now I can select star from agent client engagement view. And I get that same data with a much simpler query. And remember, going back to our access control, I can create this view and give Ohm access to this view. But because he is the reporting manager for our company, he's not going to be entering the data. He's not going to be creating the engagements. He's not going to be adding new customers, new clients. Somebody else is going to do that, but he still needs to know this data from the view. So we would give him read access here. I'm going to add this SQL script to the end of the slides and update it in a couple of minutes. So you can go back and look at it on your own time if you want to review. But tonight we don't have any extra new homework. There is a homework due tomorrow evening, I believe by midnight, for your ER diagram for Mike's Bikes. I want to see if I can get this table model to work well too, because I really want to see my... Oh, it's not really working. Oh, I know it is. There we go. So now we can see this ER diagram that we created. Or the ER diagram the tool is creating based on the database table structures we created through our SQL scripts. Any questions? We are at time.
Hey, Chris, about the ER diagram, do we just need to make a diagram to show the relationships between tables, or we have to put attributes in the tables as well?
You do not have to put attributes in your tables. If you do, that's fine, because you're probably going to later, but you don't have to for now. It's just the relationships that I care about.
Between tables, right?
Correct.
Like one-to-one, one-to-many.
Exactly right. Yep.
Okay, great, thanks.
Welcome. Good question.
I have a quick question, Chris. So my Docker is a functional now. So I was able to create the tables and stuff from the command prompt. But do I still need to download this Postgres, the SQL developer?
SQL developer,
Uh-huh.
you do not have to, but your life is going to be easier if you do.
Okay. So how do we connect those two? I think you did that, but I think I missed it. But it should be in the video, right?
It'll be in the video, but I'll just show you real quick the connections. Can I do it here? I did new connection. So here are all my connections. So basically, this is the interface that it looks like.
Okay.
So the username, password, localhost 5432. I'll update that Docker run statement as well, so it has the port exposed properly.
Okay. And my version is the newer version, so that should be okay, right?
Which
11.9, I think.
Oh, that's fine. Yeah, it should be fine.
Okay.
We're basically doing basic SQL, and we're not doing anything super specific to Postgres.
Yeah, 11.9.
Yep. All right. I'm going to hit stop recording.